This is a response episode. I'll be responding directly to comments made in another podcast. In this case, it's an episode of the Skeptics and Seekers podcast, where David and Dale have a conversation on the age of the Earth, our solar system and the universe. During that conversation, Dale picked out specific scientific ideas and commented on them in the context of establishing the age of specific cosmological objects. After the podcast went live, I responded to the blog post associated with the episode with several specific points, indicating what I considered to be errors made by Dale. The conversation that followed between Dale and myself rapidly went downhill and is no longer available to read. I have decided to go back to the original podcast episode and pull out segments that I wish to comment on, and do that in a separate episode of Still Unbelievable. Link 1 in the show notes is the new clean blog post for the episode at skepticsandseekers.squarespace.com, where you will be able to listen to the whole episode yourself. I will be referencing multiple sources during this episode. They are all numbered and listed in the show notes. I will identify them in each of my response comments, so if you wish to, you can check up on what I've said. As always, I welcome any fact checks on things that I say, and if you wish to respond or correct me on anything, the email address to use is reasonpress@gmail.com. The first half of the Skeptics and Seekers episode is talk about mythohistory as a writing genre for parts of the Bible, mainly with regards to the creation account. I have picked out a couple of things from that section to set the scene for the episode. However, it's the second half of the episode that I really want to talk about, because that's where Dale starts talking about specific scientific findings, and this is what interests me. The audio that I present from the episode is in the order in which it is in the original, though I will not be giving any timestamps for them. To set the scene, here is Dale talking about how he views the Genesis creation account.
The book of Genesis, in terms of its creation account, is an error. And in the past, I've been happy to admit on multiple shows, I think it very probably is an error.
Here Dale is affirming that he has been happy in the past to say that the Genesis creation account is in error, though he doesn't specify which parts. The reason for highlighting this comment is to establish from the start that it does not appear that Dale is a young Earth creationist. Elsewhere in the episode, Dale makes comments that further enforce this opinion. Please bear this in mind when listening to the other comments from Dale, because there are some which sound like they are taken from the young Earth creationist playbook.
What does the Bible actually say? Does it actually teach the Earth is young? It's 6,000 to 10,000 years old. Best interpretation of the Genesis text is the literal historical genre. It is literal historical truth. And once you're given that, the days are probably meant to be 24-hour days, and it gives us an age with the genealogies of about 6,000 to 10,000 years old. I think that is the best explanation given that genre.
The genre being referred to here is mythohistory, discussed at great length in the original episode. Why would the best interpretation of a genre that includes myth in its title be a literal interpretation?
However, recently I've been convinced that Genesis chapters 1 through 11 are not the literal historical genre, in the same way that the rest of Genesis is. It's actually what's called mythohistory. And once you have mythohistory in the mix, well, then you don't take the text literally. You don't have to say, oh, was there a talking snake? How old is the earth? And that sort of thing.
Early Genesis is not literal history. It's mythohistory. You don't have to accept the young earth, the talking snake, etc. Okay, but where is the line drawn? Where does literal history actually start? Dale identified Genesis 1 to 11 as not literal history. These chapters include the global flood, people with ridiculously long ages, and genealogical lists that are referenced elsewhere in the Bible. If this early part of the Bible isn't to be taken literally, then how can we trust the other parts of the Bible which rely on this early part? It is this very question that initiated my deeper questioning of the Bible and initiated my exit from Christianity. But, as I have already said, the mytho genre is not what this episode is about. I'm simply using some of Dale's early comments to set the scene that the biblical creation account is not being taken literally. With that said, we arrive at the science bit. This next section is longer and meanders somewhat, but stick with it and I'll pick out the key parts.
Does the Bible actually teach that the earth is young? and or specially designed, as opposed to formed 4.5 billion years ago through naturalism and naturalistic processes purely without God's involvement and dating 4.5 billion years.
Interesting dichotomy. Are those really the only options available?
But what are the facts in this matter?
Good question. What are the facts? Facts are very important.
Here's where I want to sort of challenge, and I want to kind of find out how skeptics reasoning. So the vast majority of scientists on the planet, and I think the majority of Christians believe, the secular model, the solar nebular hypothesis explains the formation of the planets in our solar system, the sun, as well as our planet Earth. It was a swirling ball of gas, and through natural processes, the sun gas in the center condensed to form the suns, and grains of dust and came together and formed small boulders, and those boulders came together to form meteors, and over time, over billions of years, they formed planetesimals, and those planetesimals eventually became the planets that we have, all through this naturalistic process. And it took 4.5 billion years to form naturally. God didn't need to be involved or anything like that.
Links 2 and 3 in the show notes give more information about solar nebulae. The fact that the planets in our solar system orbit in the same direction and on the same plane is evidence for the solar nebula hypothesis. The accumulation of large quantities of dust and gas into a solar system is going to take a very long time. You do not get a young system from this method.
I still think that this is most probable given the evidence that we have. However, I do think there are significant doubts that can come into play, and that young Earth creationist scientists do deserve to be taken seriously in questioning this naturalistic assumption and saying, well, maybe God was involved in this instance, or...
There is no naturalistic assumption. This is a myth that needs to die. It's a naturalistic conclusion. It's a conclusion based on past observations and evidence that have successfully described and explained everything that we do currently know about the universe we live in. Every single one of those explanations is an explanation that is fully natural. There is not one single explanation that describes something that we know that requires a God to explain it. It is this absolute success of naturalism in the things that we know that leads us to look first for natural explanations for the things that we don't fully know. How solar systems form is one of those. If you want to insert a God into any explanation, it is on you to demonstrate why that is necessary and what the nature of that God is, and how we could possibly confirm any of the details about that God. I am all for young Earth creationists being taken seriously. But first they need to produce ideas that are worthy of being taken seriously.
Maybe there's actually evidence that the solar system isn't 4.5 billion years old. It's younger than that. And I just wanted to question this second element. In order for the skeptical biblical era argument to work, you have to prove that, well, what are the facts that are inconsistent with what the Bible says, allegedly says?
What the Bible says is irrelevant. The Bible is not used as a source of scientific theories or explanations. The scientific method enables us to find out how things work independent of all and any religious texts.
I believe it's actually proven beyond reasonable doubt that the universe, as well as the galaxies, are billions of years old. I'm just convinced based on the evidence that I've seen, and I don't find young Earth creationist counters to this to be convincing.
I agree. I think the age of the universe and the galaxies within are shown beyond reasonable doubt to be billions of years old. And creationist arguments are not convincing. I am continually baffled as to why so many people do take them seriously. If our galaxy is old beyond reasonable doubt, then surely our solar system must be old too. God wouldn't let everything grow old naturally and then plonk a brand new solar system into a random galaxy. Would he?
Based on time dilation and stuff like that.
Time dilation is interesting and is part of our evidence package. See link 4 in the show notes for more information. And while you're there, also check out spectral lines by following link 5.
However, there are lower levels of designs. You can ask, well, is there design at the level of our galaxy cluster? Because there are galaxy clusters out.
Design at the lower levels of our galaxy cluster. Is a galaxy cluster a higher or a lower level than an individual galaxy? If, as conceded earlier, the galaxy is formed naturally, but the cluster it is part of is designed, how would we determine that? This is where a methodology would be extremely useful. Simply stating it as an option or opinion is not good enough.
There, right? And we're a part of a galaxy cluster. Is our galaxy uniquely situated within that galaxy cluster? And Hugh Ross, I'll list a source by Hugh Ross that goes into all these different levels and says we're remarkably fine-tuned. Our galaxy is situated within the galaxy cluster.
Link 6 goes to a page where Hugh Ross lists 60 items which are apparently evidence that the universe is fine-tuned. The first thing you'll notice about the list is that it is essentially a list of facts. How these facts show the universe is fine-tuned isn't made clear. You'll probably need to buy his book to get that information. Numbers 27, 30, 31, 32, 36, 41 and 42 mention galaxy clusters. But since this is essentially a bullet-pointed list, there is no real detail to get here.
In a remarkably fine-tuned area for not just life, but intelligent life capable of producing advanced technology such as that we have.
How do you differentiate between fine-tuned for life and fine-tuned for intelligent life? Curious people really want to know. The methodology used to determine this would be very useful. Stating something as fact does not establish it as a fact. The claim needs to undergo validation and testing.
Today, that's his specificity. That's what he's specifying. Our solar system within the galaxy is uniquely positioned so that we're able to develop the technology we have.
You heard it here first, folks. The technology we have could only be developed because of where our solar system is within our galaxy.
Also to even see and discover the universe. If we were any closer to the center, in the first place, we would be exposed to gamma radiation. All life wouldn't exist on Earth. So let alone allowing us to see out and discover the universe or discover the galaxies and stuff, we just wouldn't be able to see beyond a certain point. Telescopes would be useless.
2 points here. If our solar system was closer to the centre of our galaxy, the night sky would be brighter due to the higher number and density of stars. However, we would need to go a long way before it actually became a problem for us. Our next nearest star is about 4 light years away, and it's too small and dim to see with the naked eye. There are 7 stars that are within 10 light years of Earth. The other hazard of being in a region with a higher density of stars is the increased risk of being hit by a gamma ray burst. It's difficult to say exactly how much higher that risk is. Also note that we're not safe from gamma ray bursts where we are now, just that the risk is lower than it would be if we were significantly closer to the centre of our galaxy. Which brings the question, how much closer could we get? Link 7 is an item on our galactic habitable zone, where we could halve the distance to the galactic centre and still be okay. That's an awfully large area of the galaxy that is habitable. So calling our position fine-tuned does seem to be stretching the definition somewhat. Oh, and telescopes wouldn't be useless. We just use them slightly differently. We'd have a harder job seeing some parts of the sky because the galactic bulge would obscure a greater part of that sky. However, being closer to the galactic bulge means observing that would be easier.
If we were further out, we would eventually drift out into the spiral arms of the galaxy, again being exposed to cosmic radiation, all life killed, no advanced technology, blah, blah, blah. So
cosmic radiation is already something that we have to deal with. It is radiation that is found within the galaxy between solar systems. Mostly we are protected from galactic cosmic radiation by our sun's solar wind. Leaving the safety of that heliosphere would expose us to more of this radiation. Links 8 and 9 give some information on galactic cosmic radiation. I do not know what Dale means by mentioning it in relation to being too close to the edge of our galaxy. I suspect he's either used a confusing source or mixed up galaxy and solar system in this segment. This sloppy attention to detail makes the narrative less clear, which is a shame because when having discussions that revolve around scientific technicalities like this, accuracy is important.
But I want to focus in on the solar system as well as the planet Earth on a astronomy level. And this is where I think some questions have been coming up. So I believe that when we're looking at the planet Earth in geology and history, or on a balance of probabilities, it does show that the Earth is probably 4.5 billion years old. However, at the level of the solar system, when we look at the Earth from a planetary science perspective, there are some interesting questions. It's not the case that scientists have everything figured out, and it seems like their theories are constantly disproven, and they have to come up with new ad hoc solutions on the spot constantly.
No, scientists are not making up ad hoc solutions on the spot. This is not how science works. To make that accusation is to not understand the scientific method and how scientists arrive at their conclusions. The statement that scientists' theories are constantly disproven is demonstrably false. This is pure rhetorical bluster on the part of Dale. By definition, a scientific theory is something in which there is a very high level of confidence. See link 10 for more detail. Yes, it is true that some scientific ideas have changed over time. One example is what was taught as continental drift 50 years ago is now known as plate tectonics. This is not so much a scientific theory being proved wrong, but an idea being revised as scientists learned more about the planet that we live on. I'm not saying that science has never been wrong about anything, but being wrong occasionally is not the same as being constantly disproven. There is another very important point to be made here. How does science find out when it's made a mistake? It finds out through the scientific method. Continental drift became plate tectonics because the scientific method continued working and improved our knowledge and enabled scientists to refine what they knew. The scientific method is how we know that science has made mistakes in the past, and the scientific method is how we corrected those mistakes. Science is a continual process of learning and refining ideas, testing them against what we know to ensure that those ideas are still valid. This is what is meant when science is described as self-correcting. To question the value of the scientific method because there have been wrong conclusions in the past, when that very same scientific method is not only the reason we know about those mistakes, but also the reason we know what the right answer is to score a spectacular own goal.
This is what I want to focus on here, is the methodology. At what point does a naturalistic hypothesis for the solar system and the origin of the Earth become ad hoc, and we should favor some kind of creationism? And this is really the heart of what I'm trying to get at, not necessarily proving that they were designed or are old or are young, but yeah. So let me give some examples here. So in the first place, we have Mercury, the closest planet to the sun. So post 2008, we knew that the planet's core was massively, at least 40% made of iron, is what secular astronomers thought. And this is weird. This is physically impossible given natural theories of how the planet formed. This is just not possible to be the case at that distance from the sun.
Links 11, 12 and 13 give information about the core of the planet Mercury. Mercury has a very large core, estimated to be about 85% of the total volume of the planet. The outer core is molten and the inner core is solid. The discovery of the solid inner core is a recent finding. We are still studying the planet and we are still learning about it. Mercury also has a very strong magnetic field. This is an indication that it could have very high iron content, certainly when compared with Earth. This does seem to be the case, and in the links I posted you'll see that there has been speculation of a pure iron core. When trying to fact check Dale's 40% iron claim, I found nothing. The closest I found was a statement saying the iron inner core was 40% of Mercury's volume. This is not the same and is another example of Dale's sloppy attention to detail. Mercury having a core that is 40% iron would be astonishing, because that percentage would be way too low. As for the statement that it is not possible for Mercury to have formed naturally that close to the Sun, that is pure conjecture. We simply don't know enough about Mercury to reach that conclusion. Study is still ongoing.
Okay, well, what happened? How do astronomers explain this? And they'll come up with a plausible explanation. Well, an asteroid came and maybe it hit Mercury, and all of the lighter elements dispersed from its core floating off in outer space, leaving behind just the denser, heavier elements in its core. And okay, great. For 30 years, everyone's, oh, we figured this out. It all makes sense. But then new science, in 2008, the Messenger space probe went and observed Mercury and actually took detailed measurements of it. And guess what? This hypothesis or explanation has been scientifically falsified because it has large levels of sulfur and potassium in it. And these are volatile elements. If the impact explanation were true, then there wouldn't be these lighter elements on the planet Mercury. This is a scientifically proven fact, and it presents a mystery, and it shows, there's this element of, okay, well, this explanation has been falsified. Okay, so the question methodologically will be, well, what do we do with that? Does that falsify that Mercury was formed 4.5 billion years ago, or does it just falsify an auxiliary theory? So
Link 14 gives reasons for an impact on Mercury. There is physical evidence for this impact. The evidence mentioned in the link is about crater patterns and spin direction. This isn't about looking for an explanation for removing lighter elements from Mercury's surface. This is about explaining physical characteristics about the planet. The whole sequence about an impact being related to light elements on Mercury makes little sense, and I have been unable to find any reference to any of the alleged facts that Dale mentions in relation to this, and it's impossible for me to comment specifically other than to repeat that study of Mercury is still ongoing and we do not know everything there is to know about Mercury. Which means that absolutist statements about the history and formation of the planet should be treated with caution, especially when they are difficult to fact check. The discussion takes a break from planets and cosmology in order for there to be a comment on the process of science itself. It returns to discussion on planets in our solar system, so stick around.
In science, main theories, whether it's evolution or whatever, are protected or buttressed with auxiliary theories. So you might find a scientific evidence that seemingly falsifies the theory itself. It doesn't matter what side you're on, whether you're a young Earth creationist or whether you're a naturalist, an atheist. Most of the times when these contradictory evidences come up, we'll just dismiss it and say, well, that's an anomaly and it disproves an auxiliary theory, but we'll protect the main theory by postulating some new ad hoc auxiliary theory. So that's going to be my question in learning from David. When I'm saying these facts, I'm wanting us to think methodologically. Does this disprove an auxiliary theory or the main theory? How do we tell the difference? At what point does the main theory itself have to be abandoned in favor of, well, what's the opposite of naturalism? Creationism, or some sort of supernatural origin or something like that. So, this is kind of the questions that I'm trying to bring up here. There are other things as well, but quickly.
This is an example of where being half right is more dangerous than being completely wrong. Link 15 goes to an article discussing the role of auxiliary theories. Auxiliary theories are not there to protect the main theory. They are there to provide a mechanism to test the detail of the main theory. A simple big idea can't be tested in one go, so it gets broken down into component parts that can be easily tested. While it is true that some auxiliary theories will not have an impact on the main theory, it's not true for all of them. Let's say, for example, that someone had the idea that lightning strikes caused mutations in DNA, and that was a driver for evolution, and this is tested and found to be false. That doesn't falsify evolution, it only falsifies the idea that lightning causes mutations, and a new theory would need to be developed to explain mutations. If it turned out that DNA was immune to mutations, then that would cause a problem for the theory of evolution. Link 16 goes to a discussion on human chromosome 2, one of my favourite pieces of evolution confirming evidences. The observation that humans having one fewer chromosome than chimpanzees was a challenge to the evolutionary idea of common descent. It was suggested that at some point in human history, 2 chromosomes fuse, effectively reducing the human count by 1. Finding this fusing would be confirming to evolutionary theory. Of course, that fusing was found, and the theory of evolution got stronger as a result. This is the end of the sidetrack to the process of science, and the conversation returns to cosmology, with several sections on the planets in our solar system.
Okay, so with the Earth, a major question, how do we get all this water? Water is 70% of the Earth's surface. It's essential for life. How in the world did the water get here? Because according to this solar nebula hypothesis or nebular hypothesis, that shouldn't be the case. Earth should have been bone dry. These lighter elements could not have formed naturally through those processes originally. And so the majority of scientists say, well, we've got the answer. The water was imported. First, they said by comets, because comets have got water and ice on them. In ice form on them, right? So that's Earth was bombarded after it was formed. It was bombarded by millions of comets, and voila, we've got our water. But then this runs into problems because we've got space probes that have actually studied comets and studied the composition of them. And guess what? Actually, comets couldn't account for the water on Earth because our water is different. Comet water has more deuterium in it, for example, and so scientists have known, okay, well, the comet explanation doesn't seem to work. That's been falsified. Let's come up with another thing. Asteroids, they have water on them. They delivered. And again, once the composition, new scientific evidence says, well, actually, they have the wrong chemical composition as well. And it's been scientifically proven that no more than either 15 or at maximum 50% of Earth's water could have been added through asteroids importing it to the Earth or something like that. Okay, so that would seem to falsify the theory, right? But what naturalists do is the newest explanation I've been able to find is interesting, and they'll say, well, it's not so much about importing water in liquid form or something. It's about getting the elements, hydrogen and oxygen. And they'll say on the primordial Earth, these elements were brought here, and then the rocks melted or something, and then the hydrogen and oxygen combined. So it's literally water explodes from the rocks type thing. This theory is frowned upon by most scientists, but it's the newest thing that's trying to explain this, because asteroids, look, their ratios of xenon to krypton are totally off base. Their osmium isotopes don't match the water on Earth. So the old asteroid and comet thing, which is what majority of scientists believe today, is there are problems with it. And there are also problems with this new theory as well, because it's been there are observations that contradict it. So, okay, the methodological question, what is one to do? We've got this mystery. There are some solutions, and the more they seem to work on the face of it, but then when we study it based on science probes and the latest science, there are these problems that come up. Should we throw away the theory, or is this just a falsification of the auxiliary theories? That's going to be my question for David.
How Earth got its water has been a big question for a long time, and there are multiple suggestions for how it got here. We don't currently have a complete answer, but it is certainly true that there is not a single source for all of Earth's water. The final answer will be that Earth's water came from multiple sources. The challenge is working out which ones and how much. Water is found everywhere in our solar system, not just Earth, but also on Mercury, Mars, our Moon, the moons of Jupiter and Saturn, minor planets like Pluto and Ceres, and even on asteroids and comets. It's everywhere. Apparently Dale feels confident enough to state that on the nebular hypothesis model, Earth should be bone dry. Link 17 goes to a paper discussing how the solar nebula could provide the hydrogen required for some of Earth's water. The comet hypothesis has been going around for a long time, and comets are an obvious place to look for a source of Earth's water. Dale confidently states that Earth's water could not have come from comets because the composition does not match. Link 18 appears to confirm Dale's claim that Earth's water could not come from comets. However, unlike Dale, scientists are not content to dismiss the idea on a single piece of data. Link 19 goes to a paper discussing the water composition of a comet's coma, which does in fact match that of Earth's oceans. This is why it is important to keep studying ideas and to keep testing hypotheses. Jumping to a firm conclusion based on a single result is a poor strategy. Keep asking questions. Link 20 goes to an article on asteroids bringing water to Earth. The interesting take from this article is that the water from asteroids is seen as relatively recent, in the last million years, rather than in the distant past. This means that Earth must have had water from another source long before the water from asteroids arrived. Link 21 has different asteroid evidence. There is a category of asteroid that has rock that matches the composition of deep rock on Earth. And since these asteroids have water, it is hypothesized that there is a significant amount of Earth's water that has always been here. This means that the proto-Earth wasn't bone dry. Essentially what we have here is 3 different sources of water on Earth, and each of them with evidence that directly contradicts statements that you've just heard from Dale. Dale asked the question, when we study it, based on science, problems come up. Should we throw away the theory? It's a good question. But as you'll see from the links I've posted, throwing away the theory because of initial problems isn't the right answer. I suggest that the right answer is to identify exactly what the problem is through further study. It is entirely possible that the theory could be right, but that the problem that's encountered is the wrong data is being examined. If you don't know why the problem exists, then you can't know if it's a problem for the theory.
A couple other examples. So Jupiter and then Uranus. So Jupiter, first of all, it has certain gases. It has xenon, it has krypton on it, and I think argon as well. And once again, according to the naturalist theory, the main theory predicted, the solar nebular hypothesis, it is physically impossible for these gases to be on the planet Jupiter in the concentrations that they are. They have 3 times as much the amount. And this go to NASA's website, nobody denies this is uncontroversial. Okay, well, how should we explain that? And there is a couple of attempts to explain this. So number one, they first said, well, maybe asteroids and meteors hit it and they brought these elements. These elements can only form in what's called the trans-Neptunian object region of space, so beyond Neptune's orbit, where Pluto is and all of that. That's the only place, scientifically speaking, these elements could form. Okay, well, maybe objects brought these elements to it. Well, that doesn't work because, once again, these elements, once they get closer into the sun, they'll heat up and these elements will be gone. It will not make it to Jupiter to be delivered there. So now the other theory, okay, well, maybe Jupiter formed in the trans-Neptunian thing and then eventually wandered its way into where we are now. And there are certain problems with that theory as well.
Notice the confidence with which Dale states that science says the gases argon, xenon and krypton could not possibly exist on Jupiter in the concentrations they are in. The concentration is measured as a ratio to hydrogen. Link 22 goes to a PDF detailing how some measurements of these gases have been obtained and the ratios of these gases to hydrogen in the Jovian atmosphere. These links were made in 1995 by the Galileo probe as it descended through Jupiter's upper atmosphere. The probe sent back some measurements before it was destroyed by the immense heat and pressure of the thicker, deeper atmosphere. In the document, the ratios are compared to those we have for the Sun and are found to be around 2.5 to 2.7 times higher. Is this discrepancy to be expected? And can it be explained? Link 23 sketches out some of the challenges the data represents. One of the difficulties is that Jupiter's current distance from the Sun makes it unlikely that Jupiter would capture these gases from a passing comet or asteroid. The reason for this is that the gases would sublimate off and dissipate before the carrying object impacted Jupiter, which means that impacts are an unlikely source for these gases given Jupiter's current location. Are there other explanations for the data? As it happens, there are several possible explanations, which I won't go into here, and they all deserve further investigation. In fact, the atmosphere of Jupiter itself warrants further exploration. There is much we don't know about Jupiter, and we certainly don't know all there is to know about the composition of Jupiter's atmosphere. Given what we don't know, any firm proclamations about the origin of Jupiter should be viewed with healthy skepticism. On the formation of these elements, that's argon, xenon and krypton, it's unclear what Dale means when he says these elements can only be formed in the trans-Neptunian region. These elements, like many of the elements we rely on daily, are formed in a supernova and dissipated as part of that explosion. It could be that Dale means that the trans-Neptunian region is the only part of our solar system where it is cold enough for these elements to remain on a small body like an asteroid, and so get delivered to a planet like Jupiter. This again is an example of Dale's imprecise attention to detail, and it does him no favours at all. In researching this subject, I found several fascinating and genuinely interesting articles on the Galileo probe, too many to list in my show notes. When discussing the data the probe returned, not a single scientist said that Jupiter could not have been formed naturally, and every single one of them affirmed that more research is needed.
In terms of dating, I haven't said anything about that. Jupiter's moons, we've recently sent probes to study the moons, and we've learned a lot in the 21st century about these moons. So, for example, Jupiter's moon Callisto is the most cratered object in our solar system. And naturalists will say it's 4 billion years old, and there's very little geologic activity. So all these craters throughout its history stay on its surface. The problem is, so how do they say it's 4 billion years old? They use what's called the crater dating method. So they assume uniformitarianism. While craters are observed to form at these rates today, we'll assume they've been doing it the same over all of its history. So therefore, we can date Callisto as 4 billion years old. But this crater dating method has been totally falsified. But let's see if David thinks so. Because, so number one, in the first place, there are no craters or smaller craters. All the craters on Callisto's surface are 0.1 to 100 kilometers in length. But there are no smaller craters. If it was 4 billion years old and there's little to no geological activity on Callisto, where are all these small impact craters? They're just not there, and this is a problem for the naturalist theory.
Link 25 is a 30-page PDF study on the craters of the major Jovian moons, including Callisto. What crater dating does is give us an indication of the age of the surface of an object. More craters typically means older surface, but it could also mean higher impact ratio. There are other factors like how many large impacts and how many overlapping craters. Crater studies are extremely useful in giving an indication of how active the surface of an object is, and in giving an approximate age for the surface features, but it isn't used for precise dating of the body itself. Dale's statement on the crater sizes of Callisto is strange. He says that all craters are 0.1 to 100 kilometers in length. The lower figure in this range is only 100 meters. That's not very big. Given typical impact speeds, there won't be many craters smaller than 100 meters. The PDF already mentioned in link 25 states that they were able to identify sub-100 meter craters on the moons being discussed. So wherever Dale got his information from, it's wrong. If it were true that Callisto had no geologic activity and no craters below 100 meters, that would be weird even if Callisto was only 1,000 years old. But as stated, there are sub-100 meter craters. What is true is that the ratio of small craters to large craters on Callisto is lower than expected. The interesting question is, why is this the case? Are the small craters being erased through surface action, or does Callisto get fewer small impacts? Both are possible. But which option is the right one? Link 26 goes to a study describing how surface erosion in areas of Callisto means there are fewer craters. Maybe this explains the lower number of smaller craters.
Furthermore, it's been scientifically discovered through studying another one of Jupiter's moons that actually the assumption of uniformitarianism is false when it comes to craters, because what happens is when a thing strikes one of these moons or planets or something, a bunch of debris is sent up and they crash back down to the surface, creating a whole bunch of other craters. And this was a finding that kind of surprised naturalists, given their theory. They didn't expect so many craters to be formed from the debris of a crashing object, and it calls into question this whole crater dating thing. So again, focusing on the methodology, because I know David isn't a scientist, neither am I. I'm getting this from NASA's website and stuff like that. So, but the methodological question is what's important. These are the facts to date. what do we do with this? Do we throw out the crater dating method? Do we try to come up with some auxiliary theory to try and save it? What should we do methodologically? That's what I'm focused on.
Secondary impacts are not a new thing. This has been known about for a long time. Secondary craters are distinctive and can be separated from the population of same-size primary craters. What Dale has said in no way affects the results of crater aging. This is not new information, and it is accounted for.
Another thing is Saturn's moon, Titan. It has what's called a methane problem. So there's a certain amount of methane. 5% of its atmosphere, which is huge, is methane. The rest is nitrogen. Methane has a short lifespan. The sun will break it down into ethane and some other elements. And as such, it can only last so long. Scientists calculate 10 or at most 100 million years. It cannot be billions of years old, as naturalists believe. This provides a maximum age limit. And okay, eight skeptics are aware of this. The scientists know about this, and they realize it's a problem. It's a mystery, and they've come up with various solutions that have been, in one way or another, falsified. The latest explanation to help David out, because it's about methodology. I'm not trying to get David to refute these facts or something, but the latest theory is, okay, well, we know that it has ice volcanoes, and maybe there's these methane is being produced deep under its surface and is coming into the atmosphere through being replenished in the atmosphere through ice volcanoes. And it's been observed on Earth that in some Scandinavian country, this is happening. There's production of methane within an ice volcano deep under the Earth. So great, there's the answer. There's a problem there. So number one, it's ad hoc. There's no proof that this is in fact the source of all of the methane in thing. It's just, okay, we need to come up with a just so story to solve this problem. And secondly, there are serious scientific questions as to the self-limiting nature of this methane producing mechanism. And that's where we're at the moment. Is it true that it can form it, or are there self-limiting mechanisms? And that's what young Earth creationists will say, no, there can't be. Scientists will say, well, no, there's differences on Titan compared to Earth, so it could produce it.
Saturn is a long way away from the Sun. As a result, the moons on Saturn are a lot colder than they would be if they were the same distance from the Sun that we are. The Cassini spacecraft has taken photos of the surface of Titan, and as a result we're able to see liquid lakes on Titan. This liquid is methane and ethane. The atmosphere on Titan is such that this liquid can evaporate into clouds and then rain down again as liquid and accumulate into lakes. Earth has a water cycle, Titan has a methane-ethane cycle. The information Dale has presented here is simply wrong.
Okay, so Uranus, it's a weirdo. It's rotating on its side, on the side. Its poles are on the sides. It's unlike any of the other planets. And naturally speaking, the solar nebula or nebular hypothesis, this is physically impossible to be the case. It should not. It should be like every other planet, because they all formed in the same elliptical disk, as it's called, and in the same plane. That's why the orbits are all flat, virtually, right? They're all in the same orbital plane. They're not. One isn't like way above and way below and stuff like that. They're all in this orbital disk. So Uranus should not be on its side, for example, rotating on its side, but it is. How did that happen? All right, well, naturalists are like, okay, we can solve this problem. An asteroid hit it, a very big one, almost the size of the Earth, and knocked it over. But then through more recent scientific probes, actually that's scientifically falsified. That's impossible to be true. Because, number one, we know that Uranus has a nearly perfect orbit. Only the Earth has something better. So it's about 0.46 in terms of its orbital plane. 0 would be perfect. Okay, and also its moons. The way the orbits of its moons do not align with this impact thing. If it was just truly just an impact, it would be random. It would be not as designed looked, or looking so much designed to be where it is. It would be much more random. It wouldn't be so quote unquote perfect.
If our solar system formed smoothly and without incident, there would be no anomalies. But anomalies abound throughout our solar system. Venus has a day that is longer than its year, and Uranus orbits on its side. It's weird, but it doesn't mean not natural. It just means that there have been some major incidents during the formation of our solar system. The challenge for us is to work out what they are. Link 28 goes to a description, including a simulation video, of how an impact on Uranus could tilt it over. Planetary orbits tend not to be perfect circles. How much they deviate from that circle is called eccentricity. Link 29 contains a table on the orbital eccentricity of the planets in our solar system. Saturn, Jupiter and Uranus have very similar orbital eccentricity, but Earth, Venus and Neptune all have lower eccentricity. But notice what Dale actually said. He said, it's about 0.46 in terms of its orbital plane. The table in Link 29 says 0.47, but that's not the issue with what Dale said. The number Dale refers to is the orbital eccentricity, which is how much the orbit deviates from being a perfect circle. The orbital plane is the flatness of the orbit compared to the other planets, also known as the ecliptic. Deviation from the ecliptic is referred to as inclination and is measured in degrees from Earth's orbital plane. The value given for Uranus is 0.77. Dale has mixed up values and terminology, and in so doing has completely garbled this segment. Attention to detail is important. With reference to Uranus's moons, if Uranus is tipped over by a huge impact and ends up spinning on its side, of course its moons will follow. The stars in the galaxy orbit the central black hole on a plane. The planets around the star orbit on a plane. The moons of a planet orbit on a plane. It is predicted by physics and is to be expected.
One scientist, Neil deGrasse Tyson, who's a hardcore atheist, I even had a quote from him saying in one of, this is back in the 2007 era, and he was saying that if there wasn't, if first of all, if we didn't observe the features that Uranus has, no scientist in the world would predict it based on the solar nebular theory. It would take this modern space technology to be able to design that planet to be like it is. Now, obviously, I'm quote mining. He doesn't believe Uranus was designed, but it's just, I'm proving. Look, there is this mystery, and it's a problem, right? That needs to be explained, and it doesn't fit naturally within modern astronomical secular theories. So it's another thing that requires these explanations.
The Neil deGrasse Tyson quote is Neil saying that Uranus is weird and we would not predict this. The truth of that does not negate the fact that we can explain Uranus naturally. Unexpected anomalous things happen all the time in the natural universe. Part of what makes science so exciting and interesting is working out how these anomalies happened. Pointing at them and claiming they can't be natural is what happens when you have religiously inspired, motivated reasoning.
So basically it's been scientifically falsified. So what's the most up-to-date theory? So now scientists will say, okay, great. So an impact thesis cannot explain the features of Uranus. How about this? There are rings. Perhaps in the past there were more notable rings, and this somehow caused Uranus to tip over only to a certain degree, I think about 70 degrees. But that's not sufficient to explain its current location. So after that, then an asteroid came, hit it, and knocked it the rest of the way. Totally ad hoc, no proof for this. It's a just so story to save the theory, because otherwise it would be false. And that's where we're at today. But again, even with this impact, I would say, well, there's still this orbital perfection in terms of its orbital plane. And this is still strained, given that even if it's just a partial explanation, the impact is partly to account for this. it seems ad hoc. It seems strange. So what do we do?
On the subject of Uranus's rings, I tried to fact-check the suggestion that the rings of Uranus caused it to partially tip over and an impact finished it off. I could not find anything to confirm this idea. Everything I read attributed Uranus's tilt to impacts. Go back and see link 28 that I mentioned earlier. I have no idea where Dale got this idea from. From a physics perspective, it makes no sense.
What does an atheist do with this? Do we abandon theory, or are we open to creation at that point?
You keep using the scientific method to test and retest again ideas that you have. For creation to be true, you need to show a creator. Is there any evidence of a creator? No.
And, it's interesting that Jupiter and Uranus were both said. So one last fact that I find funny. So it's the interplay, the design of the interplay between planets. So Jupiter, remember, in order to account for the facts, Jupiter and Saturn had to be formed beyond Neptune's orbit, out in the TNO region of space. But Uranus and Neptune present problems. So in order for them to be formed, they had to be formed where Jupiter and Saturn are in relation to the sun now. And then both just happen to magically migrate to their current positions over time. So in the first place, that's totally ad hoc. There's no proof that this happens or can happen or did happen. But also there's this designed interplay, because Uranus's orbit is linked to Jupiter's stability. And as we know, Jupiter's stability in terms of its orbit and taking on asteroids and meteors saves the Earth. Life would be impossible without Jupiter there to protect us from these things. So there's even this interplay. So maybe you come up with an ad hoc thing to explain why Jupiter has this or that. You have come up with an ad hoc explanation as to why Uranus has this or that feature. And let's pretend they're equal. Okay, but then what about the interplay? Because our solar system isn't just Jupiter in isolation, Uranus in isolation. It's Jupiter and Uranus. And you've got to have these mechanisms interconnecting in a way that's plausible. And from what I've seen on the latest research, secular astronomers are nowhere near close to that. There's major issues in terms of incorporating the explanations for the problematic elements or features of the solar system and making them consistent with the other ad hoc components. So
I'm not really sure what Dale's issue is in this segment. He seems to be objecting to the suggestion that the gas giants Jupiter, Saturn, Uranus and Neptune may not have originally formed in their current locations. This is apparently ad hoc. Yet when you consider the physics involved in planet formation from a swirling cloud of gas and dust, the early protoplanets will gradually increase in mass as they accumulate more material. This early formation of a solar system will be chaotic as early planets accrete more material and begin to interact with each other. This early interaction will result in many collisions and velocity changes. During this early period of the solar system, all objects, including the Sun, will be changing mass and all orbiting objects will be changing velocity. The result of all this change means that the orbital radius of the planets would also change, either through a massive impact or because of the planet's orbital velocity changed because of a gravitational interaction. Kepler's laws of planetary motion are relevant here. There are many pages describing them. Link 31 goes to one such page. The issue of planetary interactions is basic physics. The orbital relationship between planets orbiting a star is called resonance. Planets orbiting a star in an early solar system will start with orbits that are unmatched. These unmatched orbits will result in devastating gravitational interactions, and there are only two options available at this point. The planets must fall into resonance, or one of them will suffer a terrible fate. This fate is likely to be ejection from the solar system, but it could be destruction. Orbital resonance is guaranteed for planets in a mature solar system like ours. The same is true for moons around a planet. The moons of Jupiter and Saturn have orbital resonances. Solar systems that we have spotted outside of our own have orbital resonances. A basic understanding of physics is all that's required to appreciate that in order to survive billions of years in orbit, planets must fall into a stable orbital pattern. This is not by design, this is purely natural. Link 32 is a PDF with an in-depth discussion on orbital resonance, with some fascinating diagrams that look like they were created by a spirograph. It really is a geek's orgasm. This is the end of the discussion on planets and cosmology. It returns now to more earthly subjects.
I'm attracted to the hydroplate theory of Walt Brown, which even among young Earth creationists, he's seen as a pariah. Answers in Genesis says, don't believe in that, believe in our thing, catastrophic plate tectonics or something like that. The thing was, it was this ad hoc element to the creationist responses, because I found that there was too many ad hoc components in order to answer these things, too many non-evidenced just so assumptions or explanations in order to make all of the detailed facts work and fit the flood theory, as opposed to just the secular old Earth model. And that's what sort of tipped the tides for me. And that's what I've been trying to hint at but on the level of the solar system, it's almost like it's becoming the opposite. So yeah, at what point does that scale tip? Maybe I was too premature in rejecting young Earth creationism on the level of geology, or maybe...
Link 34 goes to an in-depth discussion of Walt Brown's hydroplate idea, and why it's wrong. Essentially, the idea is that Earth's crust sat on liquid water. This water burst through the crust as part of the Genesis flood. There is more to the idea than this, and it is all wrong. There is a very simple solution why geologists and other scientists accept plate tectonics today. Evidence. There is a very simple reason why none of those scientists give any thought to hydroplate. Evidence. All the evidence shows that plate tectonics is the way to go. Be suspicious of anyone who thinks hydroplate is a good idea. It is not a good idea. It does not work. It is not worth your time. Occasionally people come up with ideas that are plain wrong, but they are so emotionally attached to those ideas that they can't let them go, no matter how much evidence is against them. These are ideas which can only be laughed at. These are ideas which belong in the bucket marked flat earth. Hydroplate is one of those ideas. Do not be fooled into trying to argue against it. It is not worth your time. Laugh and walk away is the only appropriate response.
There are atheist scientists in the 20th century desperate to prove evolution that caused them to lie and fudge the data at times with the Piltdown Man or something, but nonetheless their bias gave us some credible scientific facts. They did find legitimate findings, and that contributed to our understanding. How now we can look, what is the data, how do we assess that data, and that's fundamentally what matters the most to me. It's only once if you can prove that a religious or anti-religious a motivation, whether it's religious or not, if someone's motivation, their pet theories or worldview is contaminating the evidence, like with Piltdown Man, that was forged evidence, then I have a problem with it. But I do also just want to, even though
This segment is straight out of last century's creationist playbook, and it's disheartening to hear it repeated again. This lie should have died a long time ago, but it is kept alive by unthinking Christians who simply won't fact-check this nonsense. The Piltdown discovery was over 100 years ago. Link 34 goes to a page at London's Natural History Museum where you will find some details on the find, including links to photos, which also include a document from 1953 that gives details about it and states that it had a dubious past, and some sentence suggests that only a few took it seriously. The items that formed the Piltdown find were studied by scientists and found to be fraudulent. If this was part of a grand scheme by atheists to foist evolution belief onto the world, then it failed at many points. Evolution is accepted by the world because of the evidence that diligent and hard-working scientists have uncovered over decades and centuries. A single case of a fraud does not overturn any of that. If you are really curious about Piltdown and other attempted frauds, there is a lot of information on them, including multiple books. The theory of evolution stands on the strength of evidence, and not a single bit of that evidence is fraudulent. There are so many scientists working hard to uncover the truth of evolution that the idea that the motivations of any single individual, whether Christian or atheist, could contaminate the evidence simply doesn't wash. This is why Answers in Genesis exists as an organisation outside of the field of scientific inquiry. Their motivated contamination would not make it, so they have retreated to their own corner and painted themselves in. Atheistic motivation would suffer the same fate if it tried to contaminate the evidence. This complaint is bogus.
They don't just poke holes in theories. They actually propose their own models. They make predictions that have been proven to be true. Russ Humphreys, someone I disagree fundamentally with, he has a white hole cosmological model that proves the universe, not the solar system. The universe is 6,000 years old. I disagree with his model, but yes, that he is engaging with legitimate science and contributed. He published his work in a peer-reviewed paper. Walt Brown, he hasn't contributed to peer-reviewed papers. This is one of a criticism of him that I think is true, but nonetheless, his hydroplate theory, he makes scientific predictions in advance, and it's been published for free on his website, and they're confirmed. A lot of times his predictions turn out to be right, and they're in contrast to what the secular scientists of the day said would be predicted or we should find, and he turned out to be right. So they are putting their money where their mouth is, and sometimes some of their predictions are falsified. That has to be mentioned as well. It's not like the creationists are always perfect any more than secular scientists, but it's crucial to look at both sides. I mean, the most biased person on the earth, I don't care if you present something and I can determine it is in fact a fact, and I know how to assess facts for myself through a proper methodology. Yeah, you could be the most biased atheist. Richard Dawkins is the most biased anti-theist in the world. He's got a lot of great facts in his show, The Greatest Show on Earth, in his book, The Greatest Show on Earth. I can't take that away from him, I think scientific consensuses are practically worthless. The only thing they're good for is as an initial evidence. Okay, well, where do the experts lie as an initial factor of going, okay, there's probably some good evidence here to look into. But if that's your whole basis for believing something, if pretend that's your only claim, pretend you didn't have the other evidences or something like that, or materialism, or philosophical arguments for materialism, all you had was the scientific consensus says this. It's been proven over and over again. The scientific consensus, even within this particular scope, has been wrong over and over and over again. It's to the point where it's very weak evidence of anything, in my opinion. It just says there's probably something to see here, but go and look at it for yourself. Find out what those facts are. Don't just follow, well, the scientific consensus is the solar system is old, I'll just believe that. I don't think that is a good reason to believe something, especially when we've seen the scientific consensus in this particular field is repeatedly wrong and having to reformulate. They don't know what they're talking about in a lot of cases. Though the scientific consensus thing isn't worthless. It could potentially be used to push someone over into believing something. And it depends on the nature of that consensus. I wouldn't say it's the same in all fields.
Link 35 goes to a PDF where two Christians with relevant PhDs critique Russell Humphreys and show where he has made errors. You also get to see his short response. I have already posted a critique on Walt Brown in link 33. Individuals have their biases. This is neither new nor surprising. In the field of scientific inquiry, it is important to put those biases aside and follow the evidence and expose your ideas to as wide an audience as possible so that any biased thinking gets neutralized as much as possible. I propose that 2 indicators to check for the validity of any individual's pet theory is how do they respond to criticism, and how popular is the idea with experts who don't share their biases. If they bunker down and defend their theory by dismissing the critiques, then maybe they have an investment that's not evidence-based. If their idea does not gain any support from those outside of their bias circle, then their idea probably has no evidential merit. Walt Brown and Russell Humphreys fail on both counts. When talking about scientific consensus, we should be careful to consider what it is that we are talking about. If consensus simply means agreement within our own community, then we should not put any store in that. There is no value in there being consensus on the age of the universe from everyone in Answers in Genesis, because that organisation exists to promote a young age. For the same reason, consensus among Christians that Jesus was God also has no value, because being Christian essentially means accepting that as fact. Both of these are examples of ideas that are not only a consensus of peers, but they are a consensus idea that is extremely resistant to change. A scientific consensus should not be viewed as the same thing. A scientific consensus is not an idea that must be accepted in order for individuals to carry a label. A scientific consensus is an idea that has emerged from evidence, been discussed at length in journals, and come to wider acceptance through scrutiny and diligent investigation. Since science is an ever-changing field of study and knowledge, it is accepted that what is consensus will change over time. All you need is the evidence to back up the idea and the bravery to submit it to wider scrutiny. Link 36 goes to a description of what is meant by scientific consensus. Any consensus, scientific or not, benefits hugely when it is supported across different disciplines and therefore has multiple lines of evidence to point to the same conclusion. This is true for the old age of the Earth and the universe, and it is also true for evolution. Dale talks about bias in this segment, but doesn't appear to be aware that all those who oppose these 2 consensus topics are religiously biased. Those who accept them are both religious and non-religious. This should be enough to indicate which to take more seriously. This is the end of my critique of some of Dale's comments in the original show. If you feel the need to listen to the original to check the context of the comments, link 1 is where you'll find the original show and blog post. I will leave a final segment from Dale to play out the end of this episode. Thanks for listening, and as always, send feedback to reasonpress@gmail.com.
That would be the cap. You have to do some kind of assessment of the field and its ability for the consensus to come to reliable conditions. Just the last example, the field of cosmology. That's what I'm studying hardcore right now. It's not the solar system stuff. That was just sort of a bonus that I thought about. But the field of cosmology. I am not a cosmologist. Dear goodness, David, your eyes glazed over when I was going over those basic planetary facts. That's me with cosmos. I do not understand the mathematics behind it. I don't care about the mathematics. I just assume, hey, I just follow the consensus. If you guys say this works mathematically, I believe you. I don't understand the formula. I don't care. I just believe you, unless I find someone contradicts it or something. But yeah, that's a limit to me. I'm trying my best, but I'm limited. No matter what I do, I'm not going to be able to understand it at that level. I can understand it at a sufficient level to make an understanding on okay, what is the model? What is it alleged to do? What are certain problems with the model? How do you respond to those models? I mean, Skydive Phil, thank you so much for those videos. He responds to he has the experts themselves responding to the objections, and that's odd for the most part. You just find them, here's my theory and here's my model, and that's it. So his videos have been really helpful in seeing potential responses and that. So with that, I have an inherent limit. No matter what I think, I will only ever be able to be 70% convinced that in terms of the universe, that it began to exist, or is it eternal? Even with all of the things, I've put a self-imposed limit based on first of all, there's limits in the field of cosmology because there's stuff we don't know, but there's also my own internal limits of my understanding of what we even do know. So at most, I'm only ever going to be 70% convinced that the universe began to exist. And it's just, these are my limits. I tried my best. I was a real seeker, but if you put a mathematical formula in front of me, I'll just, all right, I'm going home. See you later.
You have been listening to a podcast from Reason Press. Do you have any thoughts on what you've just heard? Do you have a topic that you would like us to cover? Please send all feedback to reasonpress@gmail.com. You might even appear on an episode. Our theme music was written for us by Holly. To hear more of her music, see the links in our show notes.